Welcome to Study Loop.
For this problem, on the topic of waves and sound, we want to measure the acceleration due to gravity on a distant planet. We are told that a ball with a given mass hangs from the end of a wire. We have the length of the wire as well as its linear density. We then measure the time for a transverse pulse to travel the length of the wire and get a value. If we know that the mass of the wire is negligible compared to the mass of the ball, we want to find this acceleration due to gravity on this planet. So the speed of the transverse pulse of the wire, we know, is determined by the tension F in the wire and also the mass per unit length of the wire. So we know the speed of the wave V is equal to the square root of the tension in the wire F divided by the wire's mass per unit length. We know that the ball has mass, we'll call it capital M. Now, since the wire supports the weight of the ball and the weight of the wire is negligible, it's only the ball's weight that determines the tension in the wire. So the tension is equal to the weight of the ball. So the tension is M times G. And we can then use this to solve for the acceleration due to gravity. We also know that the speed of the transverse pulse is, we know that it's the length of the wire, or the length that the pulse travels, we'll call it L, in a time t. So we can write V as L over t. So if we go to our initial equation, we say V is the square root of F over M by L. And we said the speed of the wave of the wire is the length that the pulse travels in the time that it travels. And so this is equal to the square root of F over M over L. But remember, the tension in the wire is simply due to the weight of the ball. So that's mg over the mass per unit length of the string. So if we rearrange this equation, we can solve for the acceleration due to gravity on this planet. And we get g to be L over t all squared times the mass per unit length of this wire divided by the mass of the ball. Now all of these values are known, so we can find this acceleration due to gravity. So this is the distance of 0.95 meters divided by the time it takes to travel this distance, which is 0.016 seconds, and that's squared. Times the mass per unit length of the wire, we are given as 1.2 times 10 to the minus 4 kg per meter. All of this divided by the mass of the ball, which is 0.055 kg. So calculating, we get the acceleration due to gravity on this planet to be 7.7 meters per square second.